Okay, we'll get back to section 10.2 here. We're talking about area. We did problem 4. So let's take a look at problem 5 here next. It says in problem 5 that the teardrop shown below has parametric equations x equals 2a cosine t minus a sine 2t and y equals b sine t for when t is ranging between 0 and 2 pi. Find a formula for the area of the enclosed region. Okay, now the way that I'm going to do this problem is to use symmetry. Okay, if we take a look at half of the teardrop and then we double our answer, we'll get the entire area of the shaded region. Okay, now what's really important is that we have to know how this teardrop is traced out. Okay, so if t is 0, cosine of 0 is 1, and sine of 0 is 0. So I'm going to get 2a, sine of 0 is 0. 2a is 0, that point there would be my start point. Okay, when t is pi over 2, cosine pi over 2 is 0. Sine of 2 times pi over 2, that'd be sine of pi, that'd be 0. Sine of pi over 2 is 1, and so y is b. Okay, so I'd be at the point 0b, or at the top of the teardrop. If t is pi, cosine pi is negative 1, sine of 2 pi is 0, so I'd be at negative 2a, and then sine of pi is 0. Negative 2a is 0, or on the left side here, when t is pi. And then if t is 3 pi over 2, cosine 3 pi over 2 is 0, and sine of 2 times 3 pi over 2, that'd be sine of 3 pi, that'd be 0. And sine of 3 pi over 2, that's negative 1. Okay, so y would be negative b. Okay, so you bet the point 0 and negative b when t is 3 pi over 2, and then you'd come back and close this teardrop when t is 2 pi. Okay, so it looks like when t is ranging between 0 and 2 pi, would make one revolution around the teardrop curve there. Okay, now to find the area of this curve, so notice that I have a function of y. A function of y. In other words, it's going to be some curve that fails the vertical line test, right? So what I'm going to do is everything about this integral has to be in terms of y if it were handled in Cartesian form, okay? So let's see, I'm going to take f of t times g prime of t dt. Okay, well, let's see. So the y values here are going from negative b to b. Okay, x is a function of y. I'm going to take the right curve minus the left curve. Also, I'm going to use some symmetry here on this. Okay, so I'm going to get the area of the shaded region. Okay, and then whatever this area of half the teardrop is, I'll then double my answer to get the total area. Well, let's see. So the next thing I'm going to do is I'm going to match up the bounds. So when you're at 0 and negative b, that's when t is 3 pi over 2. Okay, so 3 pi over 2, that'd be the lower bound. And then when you're at 0b, that's when t is pi over 2. Okay, so I'd be going from 3 pi over 2 to pi over 2, and it's going to be the right curve minus the left curve. I'm handling the left side of this. Okay, I could, if I wanted to, find the right side of this. That'd be a different setup. I'll comment on that. But I'm going to find the area of the shaded region here. And so I take the right curve minus the left curve. Okay, the right curve is x equals 0. The left curve would be this parametric equation x of t. And then times y prime of t dt. Okay, now I've got a note here. If I had x of t minus 0, that would mean that the bounds would be going from 3 pi over 2 to 5 pi over 2, right? Because you're increasing. So here's when you're 3 pi over 2, here's where 2 pi, and then t would be increasing, so I'd be at 5 pi over 2. But that's not the interval that I was given. Okay, now I would still get the same answer if I were going from 3 pi over 2 to 5 pi over 2, but that would be a necessary thing, necessary adjustment to make. Okay, I'd have x of t minus 0 then again because I'm handling the right side of this teardrop. okay? So let's see, the first thing that I do is I switch the bounds and I throw a negative in front of the integral, okay? Because right now the bounds don't make any sense. 3 pi over 2 is the bigger number. So then when I throw a negative in front of the integral, x of t is this parametric equation, and then y prime of t, that'd be b times cosine of t, dt, okay? So then the next thing, I'm going to distribute b cosine t into these two terms. And here's what I get there on the next line there. Okay, and I see this cosine squared t, that's the same as 1 plus cosine 2t divided by 2. The 2's would cancel. And sine of 2t, well, that's the same as 2 times sine of t times cosine of t. So let me switch everything in terms of single angles there. So I'm going to have 2 sine t cosine squared t, because I already got a cosine t there. A times b is in common with those two terms, so I factor that out of the integral. Okay, so then that allows me to integrate this. If I use a u substitution on this other part, u is cosine t, du would be negative sine t dt. So I'd be integrating u squared du, right? All right, so the antiderivative is going to be a times b times t times 1/2 sine of 2t plus the antiderivative of u squared would be 1/3 u cubed. Okay, the 2 is right there in front. So 2/3 times u cubed. U is cosine t. And then we're evaluating this from pi over 2 to 3 pi over 2. When I plug in the bounds, then I get 3 pi over 2, and then sine of 3 pi is 0. Cosine 3 pi over 2, that's 0. Okay, plug in pi over 2 next, so I'll be subtracting pi over 2. Sine of pi, that's 0. Cosine of 2 pi over 2, it's cosine of pi over 2, that's 0. Okay, and so I end up getting pi times a times b. Now that's the area of half of this teardrop. Okay, so the area of the complete shaded region there would be when I double that. So 2 times pi times a times b is the answer. Okay. Let's see, so problem 6 here is where we want to set up but do not evaluate an integral for the area of the enclosed region. Okay, so getting to the correct setup is very, very important. If we don't have the right setup, there goes the whole problem, right? So let's see, in this part here, I've got a prolate cycloid. The t values are going from negative pi to pi, and the viewing rectangle, I'm going from negative 4 to 4 on each of the axes. So I have to know how this is drawn out. Okay, if I let t be pi, I'm going to have 2 pi minus 0 is 2 pi, right? And then 2 minus cosine of pi is negative 1, so that'll be 2 plus pi. Okay, that's going to put me way out here. I'm off the graph there, but I'd be right here when, t is pi. Okay, now if I let t be pi over 2, I'm going to have pi, and then minus sine pi over 2 is 1, right? So be pi minus, let's see, you get, it'd be 0, right? And then if t is pi over 2 down here, I get 2. Okay, so I'd be at the point 0, 2. And that's when t is pi over 2. Okay, so and then if t is 0, let's see, I get 0 minus 0 is 0. And then t equals 0 here means that you get cosine of 0 is 1. So 2 minus pi, 2 minus 3.14, that'd be negative 1.34. Right? So it'd be at 0 and negative 1.34. Okay, so it looks like here's what's going on. So if I let t be negative pi, I'm out here. If t is negative pi over 2, that's where I cross the loop one time. And then t equals 0 puts me down here. Okay, and I'm going to loop around. Here's where t is pi over 2, and then t is pi. That's going to put me off the graph there. Okay, so that's how this curve is drawn out. Now again, I'm going to use symmetry here to get the answer. You always have to treat this as a function of either x or y. Okay. Now I would have to treat this as a function of y because it's going to fail the vertical line test, right? So let's see. For y, I'm going to have I'm going to be integrating f of t times g prime of t dt. Okay. Well, I got the right curve minus the left curve. The right curve is the parametric equation for x, and the left curve is x equals 0, okay, times y prime of t dt. That's me inside the integral. Now the bounds, let's see, here's when t is 0, and here's when t is negative pi over 2. Okay, so I'm looping around like this way here in a clockwise motion. Be going from 0 to negative pi over 2, and I'm going to double my answer, right? So that's by the 2's in front. Now, the first thing that you do if you were to integrate this function would be to flip the bounds. The bounds don't make sense. You can be going from 0 to negative pi over 2. It would be 0, you know. So switch the bounds and then throw a negative in front of the integral. Okay. Now, if we were to integrate this function, here's x of t, and the y prime of t is pi times sine of t. Okay. If we were to continue doing this problem here, I'd have to distribute the pi times sine t into these two terms. The first part, that'd be an integration by parts thing that I do, and then the second part, that'd be a power reducing formula, okay? Because I'd have a sine squared t that I'd have to use, okay? But here'd be the answer though, if I were to do that. Okay. All we're doing is setting up the integral. So let's see. Another problem would be if we have this nephroid is what it's called. Here's the parametric equations and the t values. Okay. So when t is 0, let's see. Sine of 0 is 0. Cosine of 0 is 1. So I'd have to have 3 minus 1 is 2, right? So 0, 2, that'd be on the graph. That'd be my start point. Okay, right there. And then if t is pi over 2, let's see, sine pi over 2 is 1. Sine of 3 pi over 2 is negative 1. Right, so I'm going to have 3 minus the negative 1 is 4. And then cosine of pi over 2, that's 0. Cosine of 3 pi over 2, that's 0. Okay, so I'd be at the point here, which is 4, 0 when t is pi over 2. Okay, so that tells me that I'm going to be tracing this curve out one time on the interval 0 to 2 pi, and here's when t is pi over 2. Like I said, here's when t is pi, here's when t is 3 pi over 2, and then you're going to get right back to your start point when t is 2 pi. So, let's see. To integrate this function, I have a function of x. Okay, I'm going to take the top curve minus the bottom curve. Now, I've got the bottom region shaded because that's what I'm going to find. If I wanted to, I could shade the top region and find that area and then double the answer. Or I could just shade in part like this part here and find that area, whatever that is. I take 4 times that area, right, using symmetry. A lot of these problems are going to involve some symmetry going on. Okay, so take that into account there. I'm going to match up the bounds. Okay, so if in terms of x, Here's when x is the smaller number. Here's when x is the bigger number. So you're at t equals 3 pi over 2. I'm just matching up the bounds there. And then t equals pi over 2. That'd be the upper bound. Okay, so I'd be going from 3 pi over 2 to pi over 2. That doesn't make sense. So the first thing I'm going to have to do is flip the bounds. And it's the top curve minus the bottom curve. The top curve is y equals 0. And then minus the bottom curve is y of t. Okay, times x prime of t dt. Okay, so here is y of t. And then x prime of t, that'd be 3 cosine t minus 3 cosine 3t. Gonna go right there. Okay, and again, the first thing that I would do if I were to, integrate this would be to flip the bounds. That's going to get rid of that negative there. So I'd have 2 times the integral going from pi over 2 to 3 pi over 2 of this guy. And if I were to integrate this, I'd FOIL this out. And I would need the power reducing formula for cosine squared t and cosine squared 3t. And I would also need a product to sum formula. We saw those back in section 7.2, because in the middle you'd have a cosine t, cosine 3t term. And so you'd want all the angles to be, matching. So you'd use the product to sum formula to get rid of the multiplication there. Okay. And so anyway, if I were to do that, my answer would be 12 pi. Okay, and so 12 pi would be the total shaded or the total area of the enclosed region. Okay, because the shaded area, again, I've only got half of that, right? And so I'm doubling the answer to get the entire shaded area. Okay. So area can be difficult, but it's a lot of what we're doing here is a matching thing, and so you want to take that into account. But the first thing I'm doing is I'm looking at how the curve is traced out using these t values, and then I'm going to treat it as a function of either x or y. Take the top curve minus the bottom curve, or the right curve minus the left curve. Okay. So we'll go ahead and stop right there, and I'll pick up with arc length then in the next video.